Hello, myself Kalshetti, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technology, Solapur. Today, I am going to discuss the asynchronous counter. Learning outcome. At the end of the session, students can design the sequential circuits. Counter. A counter is a group of flip-flop. A counter is a type of sequential logic circuit that uses the memory element such as a flip-flop. Counters are mainly used for counting the number of occurrences of events or clock pulses. As we know, the counter is the group of flip-flop. Okay. Each flip-flop represents one bit. So, an n-bit counter can count up to 2 raised to n minus 1. The 2-bit counter count up to 3. The maximum count for the 2-bit counter is 3 and the minimum count is 0. Application of counter. Frequency division. Divide input clock frequency into lower frequencies. Timers. Used in digital clocks, stopwatches and event timers. Digital clocks and watches. Counting seconds, minutes, hours. Memory addressing. Generating sequence of addresses in RAM or ROM. Event counting. Counting objects in industrial automation. Analog to digital converters. Successive approximation method uses counter. Classification of counters. Counters can be classified as follow based on clock application. A synchronous counter, it is also called as a ripple counter, and synchronous counter. A synchronous counter, it is also called as a ripple counter. In this type, the clock is applied to only first flip-flop. The output of preceding flip-flop acts as a clock input of next. Means the output of first flip-flop acts as a clock input of next. It has a simple design but has a propagation delay and the speed is little bit slower. Synchronous counter. In this type, the clock is applied simultaneously to all the flip-flop. In the synchronous counter, the output changes at either rising edge or at either falling edge. In the synchronous counter, output changes at the same time. So effect of this synchronous counter are faster and widely used in industrial application. 2-bit synchronous up counter. A binary ripple counter or asynchronous counter consists of a series connection of a complementing flip-flops with the output of each flip-flop connected to the clock input of next higher order flip-flop. In this type, the output of first flip-flop acts as the clock input of next. The flip-flop holding the least significant bit receives the incoming clock pulses. A complementing flip-flops can be obtained from a JK flip-flop with the J and K input tied together as shown in figure. Here, J and K of both flip-flop are connected to logic high. A second alternative is to use a D flip-flop with the complement output connected to D input. This is the circuit diagram of the 2-bit asynchronous up counter. The counter is the up counter. This counter counts in upward direction. It consists of 2 JK flip-flop. In this type, negative edge triggered JK flip-flops are used. Means the flip-flop responds at falling edge only. It will not respond at rising edge. Here, the output of first flip-flop is connected to the clock input of second. the J and K input of JK flip flop 1 and the J and K input of JK flip flop 2 connected to the logic high input. This is the truth table. This counter has 4 states. So first state is 0 0, second state 0 1, third 1 0, fourth 1 1. After that resets the flip flop. This is the timing diagram. Let us see how it works. Initially, assume that both flip flops are in reset state. So QA, QB both are 0 0. At the first falling edge, as the J and K both are connected to logic 1, so QA changes from 0 to 1, means flip flop A toggles and the QA changes from 0 to 1. So it acts as a rising edge for the flip flop B, so there is no change. So at the end, QB becomes 0 and QA becomes 1. At the second falling edge, the QA again toggles out, flip flop A again toggles and QA changes from 1 to 0. So it acts as a falling edge and the flip flop B changes from 0 to 1. So at the end of this state, the output becomes 1 and 0. At the third falling edge, the output of flip flop A again changes from 0 to 1. So it acts as a rising edge for the flip flop B. So there is no change for the flip flop B and the QB QA becomes 1 1. At the fourth falling edge, flip flop A again toggles, output changes from 1 to 0 as the QA acts as a clock input for the flip flop B. Flip flop B again toggles, output changes 1 to 0. So at the end of fourth state, the output is 0 0. Okay. And the state of the flip flop 0 0, 0 1, 1 0, 1 1. Why? A 2-bit asynchronous counter is called as a mod 4 counter. This counter is restricted for 4 states only. The first state 0 0, second state 0 1, third state 1 0, fourth state 1 1. Again counter all the flip flop resets. This counter is restricted for 4 states. That's why this counter is called as a mod 4 counter, modulus of 4 counter. 3-bit asynchronous up counter. These are references. Thank you.